All right, guys, let's start. I'm Santosh Balasubramanian. I'm a program manager in the SQL Server Engine team. I basically work on the high availability and disaster recovery scenario. Welcome to learning more about what are we doing in the high availability space in the next version of SQL Server, codenamed Denali. So, getting started. So I just wanted to first, before even kicking off what we are doing, I just wanted to talk a little about what we have right now and why we're doing the solutions that we thought about. So actually, before starting, just a show of hands, how many people have heard or worked with AlwaysOn? Okay, there's a few people here. All right, so just starting off, high availability. Why are we investing in this? So there are certain mission-critical applications that your organization, your company, your users depend upon, and any impact, any downtime to these applications can completely impact your business processes. So these are the reasons why we actually invest in improving the availability of applications. SQL Server does have currently a lot of high availability solutions available, which are being used by enterprise customers. So some of these solutions are things like database mirroring, SQL Server failover clustering, you have log shipping, and I've also heard customers use replication for these scenarios. So here I've called out a few of the customers like Dell, HP, BWin, ServiceU, Care Group, Big Hammer, Target. All of these guys actually are using right now SQL Server to attain their high availability requirements, their high nines, like 5 nines, 5 minutes of downtime per year. So as I was talking about these applications, database mirroring, this is great for faster failover. You can take one database, you can mirror it, you have redundancy of data, so in case your disk ever goes down, you can always failover, you don't have data loss. You have SQL Server failover clustering where you have a shared storage. If any one of your instances go down, you can always failover, go to another node and bring your availability, bring your application up as soon as possible. Log shipping, this is used a lot for DR scenarios. However, despite all of these features which are available, some of these solutions are fragmented. So let me give you an example what I mean by this. Say your organization has an SLA where you have an application which has a local data center HA requirement of coming online as soon as possible, as well as you also have a requirement that you need data redundancy in another data center, the third data center. With database mirroring, you can only have 2 nodes. You can have a single database in database mirroring. So what customers do right now is use database mirroring and log shipping together. This is what I mean by saying we have the solutions, but they're a little fragmented. Flexibility points. We have heard a lot that applications depend on more than a single database. So here's where, as a DBA, as a user, you will actually have to manage mirroring across a lot of different databases in order to achieve your scenarios. So what we ended up doing is we did a holistic review of the HADR space. So we looked at customer scenarios. We looked at what are the RTO, recovery time objective. What is the maximum amount of downtime that my application can have? What is the RPO, recovery point objective? What is the maximum amount of data loss that my application can have? How is the split between your local data center and your disaster recovery sites? So then other things are, what other things are enterprise blockers for us? What are your mission critical needs? What are the online operations that we can do? Ensure that the resources are not being held for a long time. Your scenarios such as planned and unplanned maintenance scenarios, failover requirements. Looking at all these, we came up with 3 major pillars. These are our new solution, or whatever we are looking at, needs to be integrated, it needs to be flexible, and it needs to be efficient. What do I mean by this? Integrated means as a customer, you don't have to think, for my topology, for my solution, do I need database mirroring? Do I need log shipping? Do I need some kind of replication? Basically have a single unified and simplified solution where you could go and basically install this one single solution. While I talk about this, I'm also mentioning that we put a lot of effort. We're also thinking about when you look at integrated, how easy is it to deploy? How easy is it to manage the whole solution? Another thing is flexible. We want you guys to be able to reuse your existing investments, your existing assets that you have. We want to make sure that our solution works across direct attached storage or SANs, a combination of both, whatever exists in your environment. And efficient. I mean, this is the most important thing. Hardware utilization. We have to ensure that there are no idle systems, whether like in mirroring right now, you have your principal and you have your mirror. The mirror is passive. You cannot really use it. So these are some of the important things that we are looking at. I mean, how do we improve the IT efficiency overall? After looking at this, we came up with our one new solution, which we call AlwaysOn. The two aspects to this is the AlwaysOn availability groups and AlwaysOn failover cluster instances. Going ahead today in this presentation, I'm going to talk a lot more about the features in AlwaysOn availability group, do a demo on that, then talk about the features that we have in AlwaysOn failover cluster instances. One thing is, please feel free to ask any questions in the middle of this presentation. Let's make this as interactive as possible. If I'm going too fast, just ask me to slow down. All right, I will actually talk about each of these features that we have mentioned here while I get into the discussions of these AlwaysOn availability groups. All right, what is an availability group? Just setting some context around the things that I'll be using. An availability group you can think about as a container which contains all the databases that you need to fail over as a unit. As I had said, you have applications that depend on multiple databases. There are certain scenarios. We talked to certain customers who said, hey, they're using consolidation scenarios for all practical purposes. So availability group is basically a container where you can put all these databases that you can fail over as a group. And you also say all the nodes that you fail over to. So here I'm going to introduce another term. This term is replica. So a replica is basically all the nodes that an availability group can fail over to. You have the concept of a primary replica. If you're familiar with database mirroring, this is like the principle. And you have the concept of secondary replica, which is like your mirror. So I am going to use these terms going ahead in our discussions and in our demos. All right? So this is, the slide has a lot of things, but I think this is very important because this kind of says how we are trying to bring all of these different features, what we learned over the past couple of years, into this one solution. As I had mentioned, we do want to do, our main goal is having multi-database failover. So you can, I'll show this in the demo where you can select all the databases that you want to fail over as a unit. We have the concept of multiple secondaries. So as I had said, we have 5 replicas. Out of these 5 replicas, you have 1 primary, and you have 4 secondaries. Out of these 4 secondaries, you can have 2 synchronous secondaries. So basically, you have 2 synchronous copies. So you have 2 layers of redundancy in case your primary goes down. And out of these 2 synchronous secondaries, you can have 1 automatic failover pair. So to put this more in a scenario, you could think about you have your local data center. In your local data center, you want your automatic failover. So you can have 2 synchronous secondaries there with automatic failover, one of them being the primary. You have your regional data center. Your regional data center has low latency with your local data center. So you could have your second secondary there, which you can set it up as synchronous. Yes?
What is the tolerance milliseconds for a closed data center?
So we actually don't have any internal limits by which latency and things like that. We prevent you from using synchronous or asynchronous. It just depends upon your organization, what you have done in your testing. What we have noticed is generally for synchronous, people do around 20 millisecond latency between your nodes. All right? And after that, they use asynchronous mirroring. All right, so here I've also talked about synchronous and asynchronous data movement. Just to put a little contrast, synchronous data movement is basically we do not act back to the user until we guarantee that we have written the data also on the secondary. So if you use synchronous, you will not have data loss. Your primary goes down, you can always go to the secondary and get exactly the same data. Of course, the catch is, because we are also writing this on the secondary, there will be a little performance hit between synchronous and asynchronous data movement. All right, we have the other features that we have in database mirroring, such as log compression, encryption, automatic and manual failover. Automatic failover is for the unplanned scenarios. So this is basically my instance goes down, my node goes down, there's some problem. So we manage, you actually say which is your automatic failover pair, and we manage failover directly to that. So without any user intervention, your service comes back up. We do guarantee that there is no data loss when we perform the automatic failover. So it has to be a synchronous commit at that point. We have a flexible failover policy. I'll get into the details of this a little more later, but at a high level, this is basically giving you as the users the ability to decide what error conditions under which you want automatic failover to happen. And automatic, oh yeah?
Does the automatic failover still require a witness?
No. I'll get into the details and explain to it. We use clustering on top. All right, so automatic page repair is basically if you have some kind of logical errors, I believe it's 823, 824, 827, then while we do reads of pages, if this happens on the primary, we go to the secondary, get the page automatically, and repair the page. If this happens on the secondary, we come to the primary and repair the page. So this way, without any user intervention, the pages are repaired. So as you can see, there is a lot of different solutions that we have, or a lot of different features that we have added, and we hope that with this, any environment, any topology that you have kind of fits into the model. Then I'm talking about, I talked about the integrated pillar. In this, what we want to say is a failover is more than just a failover of a database. From an end user's point of view, I am connected to an application, I lose connectivity because of any failover, and they are down until they are again connected back to the application. So as a part of this, what we are doing is application failover is ensuring that we also failover the connectivity string. I will show this in a demo, kind of explain this a little more of how this works. It's interesting also because we have 5 different replicas. You can failover to any of these 5 replicas, but from your application, you need to only put a single connection string. Then we've done a lot of investments into, actually, let me do this, into the configuration, making ease of configuration, dashboard, maintenance. This is very important. You could, because you're talking about multiple replicas, you have multiple databases. You could have up to 10 AGs. You could have up to 100 DBs. We have provided a dashboard, so as an end user, you could easily see what is and monitor the health of your availability group. We also provide a very rich diagnostic infrastructure apart from your DMVs, X events. This is actually one of the things that we are continuously and keeping on working on currently. FileStream, any users of FileStream here? That's great. So you'd be glad to know that with AlwaysOn availability group, FileStream also works. It's, which wasn't working previously in database mirroring. And replication, we do the publisher failover with the replication as well. So I've kind of talked about the flexible and integrated differences that we have made. Now, to me, this is actually one of the biggest changes that we have made with AlwaysOn availability group. Efficient. As I said in mirroring, you have your mirror, which is passive. With AlwaysOn availability group, your secondary can be active. So what I mean by this is you could move certain kinds of workloads, certain kinds of operations to your secondary. Why this helps is also it removes the resources from your primary, which are being used. The kind of workloads you can move is read workloads. So any or all of the secondaries that you have defined can be readable secondaries. And you can also do backups from these secondaries. I will be doing a demo and kind of showing that as well. And the last is PowerShell. So all of this, what I've said, configuration management, everything can be managed using PowerShell.
So is that PowerShell, is that through the failover clustering module, or is that new stuff built on top of SQL Server as well?
It's new stuff on top of SQL Server. So, yeah. Do you guys know? I don't think, no, backups I don't believe can it fail over,
So
a backup?
The question is if we maintain the long backup chain when the failover happens, answer is yes. And we have a really nice tool that's built on top that will stitch together all the logs and give you a visual timeline that will help you see. So, full and long backups.
So,
So just some clarification. Are
Yeah.
you talking about taking full backup on the mirror site, or, and that capability is going to be there or not? Yes?
Full backup using copy only.
Full backup. What about a VSS backup?
We're working on it.
Working on that?
Yeah.
Okay.
all right. So I'm going to move on. As I talked about the flexibility, by the way, we have another slide where we're talking about backup, and I can request Gopal or one of these guys to give some more information when we get there. When I was talking about flexibility, I just wanted to show this slide really fast. I mean, here I have shown one of the configurations that the customer has. I think you can see my mouse. Okay, is you have 4 nodes, 4 replicas, all of these with direct attached storage. You have your local data center where you have synchronous data movement, and you have a regional data center where you have synchronous data movement. The 2 nodes participate in automatic failover target, and you have a DR site where you can have asynchronous data movement. Again, another configuration. As I had said that the always-on availability group and always-on failover cluster instances are enhancements, you can actually, both of these work together. You can have a failover cluster instance as a single replica of an availability group. So as you see in this example, the topology, the configuration is you have shared storage in one data center, another shared storage in a regional, and a single non-shared storage in a DR site, and we are using asynchronous mirroring. So here you can see what is the different flexible options that you can actually use with always-on availability groups. So before jumping into my demo, I just wanted to put some context around the demo. So let us say that the requirement from the organization is we have a mission-critical application. We want to have 0 data loss, faster failover in both planned and unplanned downtime. We want to have redundancy across 3 data centers, and our application depends on more than 1 database. So right now, the way customers would, or right now you would have to set it up is basically have database mirroring with automatic failover and log shipping to your other 2 data centers. So let me give you a demo on how we would do this with AlwaysOn. It'd be hard to give a demo without things showing up. All right, let me try that again. All right, this works. All right, so as I had described in the scenario, let me actually show you guys. Actually, I am going to go to the cluster manager in this case. So we have 4 nodes that we have defined. The 4 nodes are, sorry, give me 1 second. I'm just getting the cluster manager ready, because it'll be easier for me to actually explain this while I have these available. So you see these 4 nodes. For our local data center, as I had mentioned, we'll use AlwaysOn SRv2 and AlwaysOn SRv3. For our regional data center, we'll use AlwaysOn SRv4, and for our DR site, we will use AlwaysOn SRv5. So one of the prerequisites of using AlwaysOn availability groups is all the nodes, all the replicas that participate in an availability group needs to be a part of the same Windows Server failover cluster. I will explain it a little later why we use the Windows Server failover cluster and what are the benefits that we get through this. But you as a customer, the only thing that you need to do in the failover cluster manager UI is basically go to the UI, right click, say create a cluster, say next, select all the nodes that you want to put in here, add each of these nodes. As you've seen in my demo, I've already created the cluster. Next, give the name of the cluster and finish. And that's it. The cluster is automatically created, and everything else that you need to do is going to be done from SQL after this. So for purposes of this demo, I did exactly those steps. I created 4 nodes, added all of them into the cluster. The next step which I need to do is go to the configuration manager in each of these nodes, and all of this is just a one-time creation. Select your SQL Server instance, right-click, go to Properties, and you see this new tab called Availability Groups. You need to go to the Availability Groups. As you see, we automatically, if the node is a part of the cluster, we automatically pull that data, and you say Enable Always-On Availability Groups. Press OK, and restart your instance. You have to do this on all the replicas. Actually, we also have PowerShell scripts which are available that will enable you to do this much, much faster. So for example, here is an example of the PowerShell script. As you can see, it's very easy to do it across all nodes. I've already done this for the purposes of this demo. Once you do this, you do the setup, now you're ready to create your availability groups. So what I'm going to do is I open up SSMS. Under Management, there is an option called Availability Group. One of the things, this is one of our CDP releases. We're still working on improving the UI, improving some of the diagnostics. So the final product, we will probably see a few differences from what it is here. So to create an availability group, the first thing I do is right-click, say New Availability Group Wizard. The next thing I do is specify the name of the availability group. So say I want to use My App 1. Then, as I'd mentioned, you could select multiple databases in an availability group. As you see, I'll select AlwaysOn DB1 and AlwaysOn DB2. One thing which I wanted to point out is AlwaysOn DB4. It says it's already a part of an availability group. I had actually created another one just to show this. A database can be a part of only a single availability group. Another thing is all the databases that you want to add to an availability group needs to be in the same instance. And this is actually even across mirroring. A database can be in a single DBM, or it can be in AlwaysOn availability group. You can't have both on it. Yeah. Yeah.
Is it like there would be support where you can actually choose databases in different instances if they're on the same server? So you have a server with multiple instances. Can they bring those potentially into the same availability group?
Currently, we don't have that feature in scope, but that's interesting. We have some of our team members. We'll take notes on that and see. Oh, interesting. We'll sync up with you after this presentation and kind of discuss. Oh, the question. Sorry, repeat the question. Can you have databases across different instances being a part of the same availability group? The response is currently no, and we actually do not have that in the scope currently, but we'll get some more information and see what we can do about it. All right? So I've added the 2 DBs. The next step is specifying my replicas. So this is where I add all the separate, kind of create my topology. So what I want to do, I just want to go back to the demo and show exactly what are the configuration that we're going to do. SRV2 and SRV3 is going to be these. It's going to have automatic failover, SRV4, and SRV5. So let me create this topology right now using our wizard. All right, so I already have my SRV2. One of the things is the primary, always ensure that the primary is, you're creating the AG from the node that you want it to be the primary. The next, I start adding the replicas. I do add replica. Okay. There's some problem with the. All right, sorry guys, we have to do it this way because there was some problem with the full screen view. So now I'll add the second replica, which I had said is the local data center, SRv3. I want this to be an automatic failover replica. And what this means is basically, whenever you choose automatic failover, by default, it'll also have synchronous data movement. Then I add my regional replica, which is always on SRv4. This is in another data center, but I want there to be synchronous data movement, so I'm going to choose high safety. Please don't go by these terms. Actually, I know even in the latest build, we have completely changed this UI. We're going to use synchronous or asynchronous and manual or automatic failover, so make it much easier rather than using DBM terms. All right, so we choose high safety, and then I add my fourth replica, which is in my DR site. And for this, I want asynchronous data movement. So right now, I will choose high performance. The connection mode in secondary role, I will get into this when I do more of the active secondaries demo. So after this, I press next. So listener, this is what I had mentioned earlier, that the failover connectivity string. So what we are doing is, because all of these nodes are connected to the cluster, and whenever you create an availability group, we are creating a cluster resource. You can use the virtual network name, which is available in the cluster, to do failovers. So this is what I'm defining actually in my wizard from SQL itself. So for purposes of this, I'm just going to create something called myapp1 VNN. Let's see that. The next thing is, it says select the, so this is basically doing the seeding of databases. It's going to do some checks. Next, you can see all the actions that it's going to do for creating the AG. You can script this out if you want. I will actually just do it for an example while it's taking place. And then I'm going to click Finish. While I click Finish, you will see that we are creating all the endpoints. We're going to create the listener. We're going to join all the replicas and the databases to the primary. So while this is going on, I can actually show you guys the various scripts which are actually being run right now by the wizard. The main DDL that we have is create availability group DDL. And here, if you can see, we are adding each of the replicas to the availability group. Let me check and make sure if the AG is already created. All right. So right now what you have AlwaysOn SRv2, which is your primary, which is in, and you have two databases, DB1, AlwaysOn DB1 and AlwaysOn DB2 is a part of this AG. What I'm going to do in my demo right now is I have an application which this is just a demo app. The purposes of this app is to show you guys that using the VNN that we had created, we always connect to the current primary. So the VNN that we had created was called, and this is another thing I wanted to show you guys. You can always see all of this data in SSMS. So we had created the availability group listener. I called it myapp1 VNN. I go to my demo app. I load. I say, oh, sorry, I opened the wrong one. In my demo application, I say the data source is myapp1 VNN. And the database that I'm connecting to, let me say I connect to AlwaysOn DB1. Refresh. You see that it's connecting to the primary, which is SRV, AlwaysOn SRv2. Let me prove this to you a little more. I'm going to insert some data into DB1. Let me make sure this is actually connected to the correct server. It is connected to the correct primary. So I'm just inserting like 100 rows of C. Let's click refresh in this application. and you can see basically column 1 increased, and you are connecting to the primary and pulling this data. Yes?
Can you create an availability group of how is it moving, say, integrated security object services?
Justin, can you take this question?
Sure. So there's two things.
Um,
One is,
the question is how when we create an availability group, how are we actually managing the security permissions across availability groups? And
so the security objects that exist in master don't get moved through availability groups. It moves user databases, but there's a concept called
yeah,
contained database.
Justin, do you want? Who's kind of important?
So the server objects that exist in master don't get moved through availability groups. Only the user database does, but there's a concept that's new in Denali and part of the roadmap as you look for how we think of applications going forward called contained databases, which allows you to sever the logins and the users that exist in the database and have the users fully contain all the authentication information. So this would mean that for Windows authentication, you could have the user fully define the authenticated user for that database, and you can also use SQL authentication as well and have the password that's actually stored with the user database rather than what's stored with master. If you're looking at existing applications that don't take advantage of the contained database, then similar practices to what exists for database mirroring would work, where when you add in logins and users on one system, you add them into the other systems as a manual DBA task.
Will you be able to convert existing databases to the contained database?
The question is, will you be able to convert existing databases to contained database? And yes, you can. So if you go through, don't want to go into all the details here, I can chat with some of you guys offline, but there's basically a concept in the databases thing that says allow this to be the containment, which by default will be none. You switch it to partial, and then you can take advantage of this feature. Yes.
Probably off topic, but what are the downsides of going to a contained database?
What are the downsides? So the way that we've implemented in Denali is we're just adding in additional features. In the longer term roadmap, we would really like to have the concept of a fully contained database where we can say we're guaranteeing that there's no things that spill over. Right now, you switch it to partially contained. You just can take advantage of the sets of features that you want, or you can switch it to partially contained and have no changes to your database whatsoever.
Thank you. So going ahead, one of the things which I wanted to show you guys is we are actually connected to the primary. Now, we did some inserts into it. We read from the database. Now let's go through a scenario where you have a planned failover. So as a customer, you want to go and you want to failover to the secondary. Actually, before doing that, one of the things which I had mentioned about the dashboard, it's easier if I actually put this here. The things which I had mentioned about the dashboard, I wanted to make sure I can show you guys the dashboard. So here from the primary, as you can see, we actually query the states of all the secondaries. Are the secondaries connected? The individual database within the secondaries. So here you can see, are the secondaries connected? What is the nature of these secondaries? Are they synchronous or asynchronous? Each of the databases, are these databases synchronizing? Are there issues with this database? If you have time, I'll actually do a demo later to show you guys when there are error conditions, how does it show up in the dashboard? So imagine this flexibility when you have quite a lot more databases, quite a lot more replicas. Actually, you can only have 5 replicas, but quite a lot more databases in your availability group. All right? So now let us go through the scenario of doing a failover. So to do a failover, the first thing I do is I'll connect to the secondary that I want to do a failover to. In this secondary, I basically go down to the same place, which is management, availability groups. I select my AG, which I just created, expand the availability replicas, and now I can do a failover to this replica. So you have to do a manual failover only from the replica, or execute the DDL from the replica where you want to failover to. So when I do this, I want to open up the application that we had, which we had connected with the VNN, and show that once the failover actually happens, so right now the failover is in progress, as you can see. That is why your application is offline. Seems like So as you can see, the failover has happened. You're still connecting, your application on top is still connecting with the same VNN, which you have defined, which is my app VNN1 or my app 1 VNN. You're not making any changes to it, but now you're connecting directly to the primary instance. All right? Any questions on any of these? Yes? We stop there.
Since the most common downtime is Microsoft patching every month, are you going to have integration with SCCM so that SCCM can trigger the movement so that I don't have to have my DBAs sitting all weekend figuring out how to coordinate with my patching team?
SCCM, I'm actually not aware of. We do have. Oh, we do have. Sorry. No, it's configuration manager. Yeah, good.
It's in the future roadmap in terms of integrating the patching. So you're talking about patching SQL Server using configuration.
No, I have to patch the OS every month.
Okay.
Right? I mean, I've got threats at every level. I have to patch every month, right? And that's the #1 downtime to my application. And if that's the performance of this, you haven't given me any benefit every month over clustering today.
So
The app was down.
absolutely, right? So completely agree on the planned downtime. So in terms of, so that's what we're working with the system center folks to actually integrate that into the future release of the product. But one thing that we want to point out from a planned downtime perspective is that
Oh, sorry. Can we get a mic up
Oh,
here, please?
sorry. So the question was around what is the System Center story for patching? And that's something that we are working with the System Center team for the future roadmap. And the main question here was, hey, what do we do with planned downtime around patching? And one of the things that we are doing new, and Santosh will talk about it, is the server core support, right? So now you can run SQL Server Denali on Windows Server Core, and that really reduces the patching requirements depending on the roles that you have enabled and the type of patches that you apply. So that's something new that you're going for, the benefit that you're going to get for planned downtime. But that's in the roadmap for System Center.
Similar question. To do with the failover, what is the effect to the connectivity? You just saw a demonstration that while it was failing over, you couldn't get a connection. Is it totally offline during the time window between being from one place to the other? Or is it only stopping new connections? What's the behavior?
Yeah, so the connection behavior is essentially there's an application disconnect that happens. So the application on retry basically gets redirected to the right instance depending on whether it's a read-write application or a read-only application. So there will be a disconnect to the application, and we are not maintaining states as we fade over.
So bottom line here is that the application still has to be aware.
Correct. Yes. Application need to have the retry logic to connect back to the instances.
You should keep that. Application doesn't have to be aware of the secondary.
Right.
It's only because this is where we are using the virtual network name. We are using the VNN in order to do. So from your application standpoint, you're only saying that at any time to connect to the primary, I have to connect to this one VNN that I have defined on my AG.
Right, but you have to have every application have the retry logic to handle the duration of time between
Yes.
one and the other.
Yes, you'll have to do that. I'm sorry, I couldn't hear that. Yeah. So, so the question is basically, when a failover happens, can you actually bring the different file groups online? Can you alter the file groups while you're actually starting the node on a new secondary? Is that the correct question? The sequence. No, we are actually using the exactest database mirroring logic right now when we do a failover, and my understanding is that you cannot alter the sequence around failover. We'll actually validate and get the answer to this question. We should sync up. So the question is, can you change the sequence of file groups while you bring things online? No, you cannot.
No, you can't. It just brings on, it goes through standard database recovery for the full database as it's starting up.
backup. In today's mirroring, you have to bring it, take it back up, bring it over, restore it, take a tail log, bring it over again.
Uh,
You have to go through anything like that.
no. In an automatic or a manual failover without data loss, you don't.
To go back.
No, no. So if you can see, so is the question. So is the question basically, does the previous primary come back online and do log shipping when the failover happens? Do you have to do something else?
Primary goes down, you're now on the secondary.
Yeah.
You then fix the problem that is on the original primary.
Mhm.
What's involved in getting that back in sync?
So what you can do is there is this concept of resume database that we do if you've done something like a force failover. So when you do a force failover, you fix the problem with the primary, your primary comes back online, and you can do a resume database at that point, which actually starts the log synchronization with the new primary. Yeah, it's just exact database mirroring kind of a log shipping. No. It's actually a DDL that you can run, or you can also go to the wizard, the UI, and you can right-click the database, and it says, hey, resume data movement.
So we're able to internally keep track of where exactly the previous primary was, and we will undo what it had ahead of the time. And there's the two failovers. You have the manual failover and force failover. Manual failover saying everything is synchronized, in which case, as soon as the primary comes back online, we'll go and take care of resyncing them up and catching them up. If you did a force failover, you're saying I'm allowing the system to take data loss, where that old primary has data that doesn't exist on the new primary that you failed over to, at that point we will go and suspend the database over there to give you a chance to go and recover the database, the records that were committed over there, not sent over to the other side logically. And then once you're done and say, I really want to get this thing back up and running, you issue a resume command. We internally know how to go and move the database physically back. There's no recovery or logs that need to be sent over to the other side. And we can do that for one force failover. So as long as you've synced to the last time you've done a force failover, you should not have to go and restore from backups to get the system up and running. Yep.
All right, so moving away from the demo, just basically talking about what are the things that we showed. I'm going to go through these slides really very fast because I want to go through other aspects of active secondaries. So we showed that for an availability group to fail over, you have a primary, you fail over both the availability group and the VNN together. So if there is a failure, both the availability group and the VNN moves to a new node. This becomes now the new primary, and your other secondaries join and reconnect to it, and log shipping starts. The other thing which we actually talked about already is a contained database. So there are certain objects, such as logins, which live outside your databases. So what we have done, exactly as we had explained earlier, we have the concept of contained database at this point, where you can bring logins, objects like logins, into the database. You basically right-click a database, say that I want to make this a contained database. And when a failover happens, a login fails over along with it. Some of the limitations of this, certain objects such as jobs do not fail over along with, is not a part of the contained database. So you guys still will have to manage it separately for failover situations. And we are working on this right now. We don't know what timeline we'll get the jobs into the contained database. All right? No, MSDB cannot.
I have a question about your failover. Is there a way to add additional logic on the back end? Say I want to activate jobs and stuff like that. Can I plug that into my failover, or is there?
So I can see this actually being used with something like if you're having certain jobs where you're doing manual failovers and things like that, I don't see why you cannot add to the end of those jobs.
But in like an automatic failover situation, can you take and add that same,
It'll be,
you have SQL agent jobs that are on the other side, but they're deactivated
yeah.
because,
You can. So you do have the concept. I mean, some of the things that we do have X events which says when a node becomes a primary. You have DMVs which say when a node becomes a primary. Depending on if you can listen to those events, if you can query those DMVs and say when this becomes a primary, I want to run a set of jobs.
There are two ways to go about this. The recommended approach is if you do have control over the jobs, to have up front in the job to say, if primary, then do this job, if otherwise, skip the job, and they'll give you a clean way that you're actually not even turning on and off jobs. Other thing you can do is you can listen on to events and build a simple, we'll actually have a blog post soon on how to go listen on the X events, and then when you hear the X event that, hey, I'm the primary, to go and turn on and off the job. But if you can do the first one, that probably would be my recommended approach of how going about doing that. It depends on whether you have control over the jobs, though.
All right. So the next thing I wanted to talk about really fast is the availability group architecture. So I had said that all nodes of availability group, all replicas need to be the part of the same Windows Server failover cluster instance. The reason we do this is because in order to get this distributed system working, you need to have internode health detection, failover coordination, primary health detection. There is some common data which needs to be stored across all of these nodes. So a platform which already allows you to do that, platform which allows you for change notifications. So for this software solution, we are using the Windows Server failover cluster. This is actually a solution which is used by also other Microsoft products. I mean, it's becoming more and more used. Got to give it up to the Windows team. Since 2008 R2, they've made some significant changes to this. Managing this is much easier than it was earlier. And as I mentioned, we use it, the AlwaysOn failover cluster instance, AlwaysOn availability group, Hyper-V, Exchange, and there are some built-in workloads, file share, NLB, etc., which use the failover cluster. All right? So the next thing which I wanted to jump into is active secondaries. As I said, one of our goals is ensuring that there is no idle hardware. It's up to you guys as users to decide when you have multiple secondaries, when you have multiple replicas, how can you utilize those secondaries? How can you utilize those replicas? So in order to do this, we provide two kinds of things that you can do. You can either do your read applications out of it. So you can have some kinds of reporting applications which can read from these active secondaries, or you can offload your backups to these active secondaries. As I mentioned, all of your secondaries can actually take one of these roles. Actually, both of these roles at the same time. All right. So to talk about, just give an example of how readable secondary works. Say you have a primary, which is instance A, and you have your secondary on instance B. Your read-write application can go to your primary. Your reporting can go to your secondary, which is your instance B. In case there is a failover that needs to happen, your instance B becomes your primary. Your read-write applications are now going to your instance B, and your reporting applications can actually go to instance A. So readable secondaries can be used to offload read queries here to the secondary. One thing is, this will only be close to real-time data. It depends upon what kind of synchronization you're using, depends upon the redo queue that you have. If you're using synchronous data movement, then there's a higher probability that you're going to be closer. But it is also dependent on your redo queue. Any questions on this?
Yeah, so the application would reference it as MyApp1.
For
And so the failover would direct it to the appropriate.
MyApp1, which is for the VNN, that is only to the primary. I will talk about that in actually 2 slides from now and show a demo of that.
And you might cover this when you show how to reference it. But what happens if you have a failure and machine's hard down? Is that so now your secondary becomes your primary, and your app's coded to go to the secondary for reporting. Is reporting completely down, or does it redirect to primary?
So we do have the concept of read-only routing. And in read-only routing, you can actually say, if you have multiple secondaries, I want the connection to go to one secondary first, and then you can give you a list of secondaries. And I'll talk about some of the configurations that we have, because actually, let me go there first, and then I'll come back to the previous slide. So we have this concept of read-only connectivity and read-only routing. So what this means is there are certain applications that you have which you never, like a reporting application, that you never want to connect to your active primary. I mean, it's probably, you don't want to use up the resources on your primary. So for this, you have the concept of a read-only application intent that you can put on your primary. So what happens is, if you have a read-only application intent, which you have in your connection string, you will, and your reporting application tries to connect to your primary, we reject that connection. In that case, your reporting application will be down. But this is the configuration that you choose. You also have the concept of read-only application intent to the secondary. So what happens in this case is your secondary, you can basically set, and I'll show this to you guys, you can set, I want my secondary to only accept read-only connections. So you set in your connection string an application intent of read-only, point to the instance name of the secondary, and in case, only if it is a readable secondary with read-only enabled, it'll allow you to connect. So now let me talk about read-only routing. This is the failover scenario that you had talked about. So you can set, while creating availability groups, you can set a routing list. You can set for when one of my replicas is the primary, what is the sequence that I want the reporting application or my readable application to fail over to. I will show a demo which actually makes a lot more sense around how readable or read-only routing actually works. So let me jump to the demo. All right, so for purposes of this demo, I'm actually going to create another availability group. So here I'm going to call this availability group, say, my app. I'm going to select a database, which is DB3. And I'll just specify a single replica just to make this a little more easy and straightforward. And here, if you see the connection mode in the secondary, this is the read-only intent that I had mentioned about. And all connections is basically, I want to accept also readable secondary connections if the application doesn't have the read-only intent on it. So for purposes of this demo, I'm just going to select all connections. Press next. I'm going to give it a VNN name, say my app 8 VNN. And let's create this AG. While this availability group is being created, what I'm going to do is I'm going to show you guys how do I set up the routing, read-only routing list. So here, so I had created the name of the AG as my app. I'm going to say that any connection, any readable connection which comes to my AG, when it goes to AlwaysOn SRv2, I want it to use the URL, TCP, AlwaysOn SRv2, and the port associated to this. So I'll have to do this for all the replicas which are there and which I want it to be readable. And then what I'm also doing is I'm saying that when my primary is on AlwaysOn SRv3, I want the readable connection to automatically go to AlwaysOn SRv2. And similarly, when my primary is on AlwaysOn SRv2, I want all the readable connections to go automatically to AlwaysOn SRv3. So let me make sure that the AG is actually created. This is taking a little longer time. All right, we have our myapp1 AG. I'm going to execute this DDL. And then I'm going to show you guys through the demo what I'm talking about. So in this case, I have one application which is actually going to connect to my primary. So I'm going to call this with the VNN that I had created, which is my app, I think I had called it my app 8 VNN. Sorry, let's look this up. My app 1 VNN is what I had called this. Sorry. Oh, there is an R in the end. I don't know why I did that. All right. So my app 8 VNN R. So in this case, what I want to show is I am going to connect directly to my secondary, even though from my application I am using the VNN which I've created for the primary connection. for doing this, what I say is I want the application intent, which is what I add to the connection string. I call the application intent read only. So when I do this, you can see that the primary is actually on always on SRv2, but because I used myapp8vnnr and application intent as read only, it is connecting to the secondary automatically and pulling data from the secondary. Let me also kick off another instance of the application and connect to the primary. What this will do is you can basically see when I do the failover, how that failover actually manages both the primary and secondary failover. So here I'm going to say myapp8vnnr and database 3, remove this. So this is going to be my primary. So it is connected to SRv2. So now let us do a failover. So I go to my application, I connect to the database, sorry, the node replica that I want to failover to, and I do a manual failover to this replica. I select the replica, and I am doing a manual failover to this. Come on. So what is happening when I do this failover? When I'm doing this failover, basically, the cluster is going to ensure that my VNN, which I have defined, is always going to connect to your primary. But because of this application intent that we have put in, our readable secondary application will always connect to the secondary. So now that the failover has happened, let me prove this to you guys. So this is my primary, which is connected to myapp8vnnr. I refresh this. You see that it is now connecting to the primary, which is my AlwaysOn SRv3. My secondary reporting application is connecting to SRv2. So this is basically the failover that you had mentioned. Any questions? Yes?
So active secondary, is that only read-only, or are you able to do CRUD to the active secondary?
No, you can only have read-only in active secondary. Any other questions? Okay. Yes, you can. You can do backups from the secondary. So let me actually, this is the slide which I had skipped by because we were talking about more of the read-only aspect of the secondary. So as you can see, you can do backups from any of the replicas. You can do it from the secondary replicas, or you can do it from the primary replica. And when log backups are done, all replicas form a single log chain. And we also have the concept of a database recovery advisor. And what this does is, it actually is a UI format which shows all your log chain, and you can actually decide at what point do you want to do the recovery from. I think in the 400 level, there is another 400 level session, and we can see if we're going to do any demos on that. Mm-hmm. I'm sorry, I didn't catch it.
So the way the backup from secondary works is essentially backups can be both the full backup and log backups can be offloaded to the secondary. So the question is, you need to have jobs running on all these different instances, and how do you determine where to actually take the backup? So we have a built-in function that basically goes and evaluate which is the current primary, which is the current secondary. You can also set priority on the secondary. So you can say, I want to take backup on this secondary first. If this secondary is not available, move on to the next secondary. So this information is centrally stored, and this internal function can actually go and determine which is the right secondary or right instance to take the backup from. To answer your question around the jobs need to be created on all the instances, And when the job runs, during runtime, it determines if it's the right secondary to take the backup from.
Can I follow up on that?
Sure.
One? Saying, what happens if the failure happens during the backup? What then?
So the whole thing about maintaining the log chain. So let's say the backup or the server goes down when the backup is happening. So what we do is we also maintain the truncation points. So the truncation points is all based on the backup that's taken across any of the instances. So we don't truncate the log across any of the secondaries until we actually have taken the backup. And we have that information centrally stored. So there is never a case where the backup chain is broken, even if one of the instances go down.
What process would you have for continuation? If the server that you had that had started the backup, how would it be reinitiated on the next system in line?
Correct.
You're only checking at the beginning.
Right. So what's happening is that the jobs are running on all the instances, right? The backup jobs are running on all the instances at all times. But the internal function make the determination whether the instance that the job is running on is the right instance to take the backup from. So even if one of the secondaries go down, the failover happens, the jobs that are running on the other instances will determine whether that's the right secondary to take the backup from, and the backup will just continue to happen.
What if the backup's already started? You've already made that check.
So we'll make the check in the beginning of whether to run the thing. If the backup, like the log backup hasn't completed, then it won't move the truncation point forward. So the next time the log backup will get taken, it would take from the last time the backup was actually completed. Does that make sense?
Yeah.
Yeah.
No, so that can leave you with a gap in time in which you don't have active backups.
It would leave you a gap in time from the time when the last backup started to when the next one would run. And so, I mean, when you have a failure in there, you could always go and kick off the job manually if I know that hey, I need to run them every 10 minutes or so. So the job would get kicked off on all the systems. Each one of the systems would go and see, here's the order in which the backup order would be looking at. It would say, if I'm the top one in the order that's online right now, then I will kick off the job. And so that's how they determine when to kick off the job. And then on completion of the job, then they will go and move the truncation point. So if I kick off the job and all of them go look at the thing and says, okay, this one guy is the right guy to kick off that backup, and he starts running the backup, if he fails partway through, the next time the job gets kicked off on one of the other systems, they'll see, am I the highest priority guy to kick off the job, in which case then they will proceed to kick off the job. And since the previous one didn't actually complete the log backup, the next guy to kick it off would take the duration of the previous guy's log backup plus the next interval.
That makes sense for the transaction mode, but what happens if I'm a half hour to a 3-hour full backup?
So the full backup, it'll be the same. I mean, it's a full copy-only full backup, so we're not cleaning up the diff maps anyway. And so if you were partway through that full backup, then that backup itself would fail. It would be similar to just running on a standalone box and the backup failing. You could either go and kick off the next backup and it'd start from scratch, or you can wait for the next time it gets kicked off. But there's nothing special there that's done to go and say, I have half the stuff, can I resume halfway through or anything like that?
Right, but I'm thinking that if it fails partway through, how do you get the full backup done for that night? Do you have to have other jobs kind of watching, saying, oh, it failed, therefore have the backup start again?
Yes. If you had a failure, you'd have to listen to an alert and have another job get kicked off over there. Yeah. If there are more questions on this, let's take them offline. There's also at 8:30 on Wednesday, we're doing a session which is basically not as much on the conceptual stuff, building all these things end-to-end and taking advantage of each one of the features. And so that'd be a good time where I'd walk through the read-only routing, the offloading, the backups, and how those pieces work as well.
No, there is no distributor failover in AlwaysOn at this point. It's not enhancement. We are keeping to the same functionality as DBM where you have publisher failover. So, all right. So really quick, I want to talk about the AlwaysOn failover cluster instances as well. So here we have done a bunch of key investments and key enhancements. The first thing is, of course, faster failover. We've done some work in the recovery stack in order to improve this. Native support for multi-subnet failover. So what this is you could have your data centers with separate subnets, and the Windows cluster actually manages. You can define from your application layer just a single virtual network name, and the Windows cluster will manage, even though you are failing over across subnets, your application can connect to the correct primary or readable secondary in this case. We have also done some investments into faster failover for this case. I'm sorry, what is good? No, please.
I'll follow up.
Okay. So with cross-subnet failover, one of the main things which I wanted to add is you would not get impacted by the DNS propagation delay because we have done some investments in a connectivity space to help with that. By the way, this not just works for failover cluster instances, but also works for availability groups. The next thing is flexible failover policy. I have a slide later to kind of explain that in a little more detail. The SMB support, so basically the 26 drive letter limitation that we have, we kind of gotten rid of that. So this helps more in consolidation scenarios. And then another investment that we have done is moving the temp DB onto a local drive rather than having it on your SAN. So going ahead, just wanted to introduce the flexible failover policy. So currently, until SQL 2008 R2 with SQL Server Failover Cluster instance, the way we know a server is online is by just querying @server name. The problem with this is it can, during thread starvation, when there is too much load on your node, it can lead to false failovers. So what we have done with Denali is now we have a stored procedure which is running in SQL Server, which collects diagnostics of your SQL Server. It collects data like, are there any spin locks? Is there too much dumping? Is there any unresolvable deadlocks? And this information is sent up to resource DLL. We also actually write this information to log, so you guys could actually use diagnostic tools. You could know exactly what's the health of your system. Now, as a user, what you can say is, I want my server to failover, do an automatic failover, only under certain given conditions. So we have defined a 0 to 5 bucket in SQL Server Failover Cluster instance and a 1 to 5 bucket. So you can say 1 is something like, I want to failover only when my instance goes down. While 5 is, I want to failover when there are some unresolvable deadlocks. So you as a user have more control over exactly when you want the failover to occur. All right? So apart from this, we have also done some investments for reducing the planned downtime. This is what you asked about. One is support for Windows Server Core. As you guys know, Windows Server Core is a stripped down version of Windows Server. So the amount of patching which is required on this is also decreased by around 50 to 60%. We have support for rolling upgrades and patching. This is for both availability groups and failover cluster instances. Faster failover time, we've done significant investments into that to improve your failover time. And last, which is very essential, is more online operations. So lob column support was not there previously. We have added lob column support as an online operation. Another thing is adding column with default. So earlier, if you have a very, very huge table, millions of rows, if you add a column with default, it takes a lock on the table, which actually impacts availability to the table. Now, we have done some enhancements where we are writing to the metadata of the table, so the amount of time that your table will be locked will be significantly lower. Hence, we increase the availability. All right, any questions at all? Please? So your question is, what is the process of putting schema changes out when you have up to 5 secondaries? So basically, the scenario is I'm making some schema changes, and then I have a failover at that time. So how does it update? don't. But let's, do you, I don't, yeah, you just push it to the primary and that does the replication or data movement to the secondaries. With a synchronous secondary, you know that it'll always be there, but if the failover happens in the middle of it, then you will have to do some kind of a forced failover with data loss and redo your changes. Did that explain it correctly? Okay. All right. So what do we have right now and what will be available in the next CDP that we'll give out to customers? So right now, you have the rich configuration. You can create AGs. You can create multiple AGs per instance. You have synchronous, asynchronous data movement, multiple databases support. You have read-only access to the secondary, but with the next CDP, this would not be production ready. You have file stream support, and of course, all the client connectivity support that I've talked about in this presentation. You also have contained databases and all the SSMS, catalog views, all the supportability enhancements that we have done for availability groups. All the features of SQL Server failover cluster instance is also available in the next CDP, which will come out. So one of our requests to all the folks is, please sync up with us if this is something of interest to you guys, interest to your topology, interest to your organization, and we would really like to see how we can get you on board with the next CDP. The follow-up sessions so there is one follow-up session which is happening on Wednesday, which is the 404 session at 8:30. There is one session, interactive session, which is happening tomorrow at 10 o'clock with the product team members.
And there's another one Wednesday afternoon, specific on AlwaysOn with the product.
All right. So this is, you guys have access to the slides and you'll see the resource center. We have the blog, we have the CDP, which is already public download, which has asynchronous data movement, and you can have a single secondary on it. And there's information about all the forums. So in conclusion, I hope you guys got a good understanding of what are all the features that we have done with AlwaysOn Availability Group, how we have improved the flexibility to you as an organization, how we have integrated all the different solutions, the enhancements that we have done to AlwaysOn failover cluster instances, management experience, and integration with System Center Management Pack that we are actually going to put out as well. We have filled some very important gaps, such as improved online operation, more help diagnostics, AlwaysOn on Windows Server Core, support for actually removing the drive letter limitation. And in the end, basically, the solution that we have built right now with the Denali is what we are hoping is going to be the foundation for the changes that we do in the future in SQL Server for high availability. All right? So that is it. So the breakthrough sessions.